audience, dear chair. Just before the coffee break, I would like to introduce you my topic. I'm exploring possible therapeutic interventions for the critically ill with a special focus on the microbiome. My name is Dilan, Márk, Karim, and I work here at the university at the Clinic of Anesthesiology and Intensive Care Department. And my vision is that science one day may overcome quackery. For that, our mission nowadays is to understand better and disseminate better the beauty and the pitfalls of evidence creation. I have 3 ongoing projects, all related to optimize care for the critically ill. In my first project, I'm collecting and analyzing evidence regarding to the extent of dysbiosis in the critically ill. And in the second project, I'm looking into a possible preventive measure for the prevention of alcohol withdrawal syndrome by substituting those patients with ethanol, which is a controversial but widespread practice all over the world. And the great evidence is still lacking behind its use. And in a third project, I'm planning a study to assess the safety and the efficacy of esophageal core temperature management in those patients. Due to the short time frame today, I will introduce you my first project in detail, which is the investigation on the extent of dysbiosis. Let me first just clarify some definitions for you. The billions of bacteria of hundreds of different species that are living with us and fighting with us and also suffering with us is called our microbiota. It's constantly evolving and adapting with us in a cooperative manner. And our immune system, our immune cells, the epithelial cells are in a strong cooperation with those microbial communities. We are still started to understand how to describe and examine those microbial communities. And we know that if any harm happens to these, because we get any insults or these microbial communities selectively are insulted, we can see a change in the composition and the loss in diversity. That's what we can call dysbiosis. The problem during critical illness is that the illness severity and the specific interventions as well lead to dysbiosis, and we already know that serious secondary infections may arise due to the overgrowth of pathogenic bacteria. Dysbiosis is related to mortality and morbidity, and we still don't know the exact extent and the factors affecting diversity and dysbiosis. Our aim here is to analyze this relationship. What is the extent and what are the risk factors for dysbiosis in critically ill patients? Our hypothesis is that it's frequent and it's influenced by distinct critical illness associated conditions. And by increasing awareness on dysbiosis, we think that it may lead to more appropriate testing and maybe the implementation of possible preventive measures. After a systematic search, I had a great pool of publications to work with, out of which I now have around 140 eligible full texts with more waiting for data clarification by authors. And I'm collecting the 3 main diversity indices as outcome measures and also bacterial composition patterns data. I already finished the extraction of papers regarding and examining gut dysbiosis to assess the loss of diversity compared to healthy controls and any follow-up changes after admission. And the extraction goes on for respiratory tract and skin dysbiosis and also other indicators of dysbiosis. We also started to reanalyze the raw sequence data that are uploaded to repositories in order to have individual patient data analysis and to become independent from the original publications, but I will talk about this later. First, let me show you my results, my preliminary results on this ongoing analysis of gut dysbiosis. In my first forest plot, you can see a diversity index called Shannon measuring the healthy control population's gut diversity. Here to the right side, higher Shannon diversity indices indicate a higher, more diverse microbiome, and to the left, it's an indication of less diverse microbiome. So we can use this healthy control as a diversity baseline. We had a pooled mean of 4 here, and considering the critically ill population, measuring their dysbiosis just after the admission, we get a mean on this Shannon diversity at around 3, which is reduced. And we also examined the critically ill population during their ICU stay or after their admission. And we found very similar decreased mean results in their diversity. So comparing those numbers, we can see that there is a difference between the healthy and the critically ill gut diversity, which is represented here by the Shannon diversity index. We can say that critical illness is associated with the loss of diversity, and this disruption occurs early days of the critical illness. This is by far the largest analysis on the topic, and we have a huge database of healthy control and a very diverse and very big critically ill population, which are the strength of this study. But there are problems, quite big problems. If you remember, this was my forest plot for the healthy controls. What you can spot here is that the results are ranging from around 2 to 6. And if you remember, the pooled mean differences, which were significant between the control and the exposed group, was around 1. So there is a 4 times higher between paper difference than the difference was between the exposed and control groups, which is a problem of comparability. And this compromised comparability is arising from the differences in sequencing methods, and mainly the differences in taxonomic assignment, and also from the different baseline characteristics. To overcome this, we are planning a reanalyzation of this obtainable raw sequence data that are staying in data repositories online, and make a new standardized analysis by our mathematicians, and to align those results with the patient characteristics and treatment effects in order to have something like a retrospective registry, and to be able to run an individual patient data meta-analysis, which is considered to be the gold standard of metas. By this, patients can be reclustered based on special factors of interest, and we are independent from the original paper. This is how our individual patient data meta database will look like, where on the green we can collect all the baseline data for the patients, like lab results, scores, outcomes, any treatment that they got. And here the lines are representing not one paper, but one patient. And we can align these standardized calculated diversity indices and composition indices to these patients, which would come with a much greater quality of data. Of course, the road is long, and this is a big work ahead, so progression is hardly definable in this way. But I believe that discovery consists of seeing what everybody has seen, but to think differently, to think that nobody has thought before. Thank you.
Thank you for the presentation. I would like to know what are the perspectives for the treatment of dysbiosis or use of probiotics at the critically ill. What is known, and what are the horizons for that nowadays? Thank you.
Thank you. It's a very good question. That is the soul of the next step, which is not resolved yet. There are options like probiotics, fecal microbiota transplantation, changing in diet, but there were big studies assessing the outcomes with those, and the results were not making the examiners happy. I ran in some papers which were analyzing the effect of probiotics, and they gave the probiotics in a very nice measured manner, but when the microbiota was sequenced, not a single cell of this probiotic bacteria was identifiable there. So that's going to be the next step to come up with an idea to restore. But prevention here would be the first step to, as much as we can, prevent the insults to the microbiome.
And how much time do you need to get these results? So what is this bacteriosis on these critically ill patients? Because they're critically ill, so we do not have much time.
Yeah. The first problem that it's very expensive, and the second is that the process of new generation sequencing, then the aligning of the results and the mathematical and graphical analysis comes much later. So as a diagnostic method, it's not working yet. But if you imagine back some years ago, the sequencing of bacterial communities to diagnose one illness caused by one pathogen also seemed like unachievable in the next decades. And now every day we are using the BioFire and multiplex PCR to identify selected bacteria. And what the market did is that they came up with a big machine for a lot of money where you put in the sample and it does it in 2 hours. And that's possible with next generation sequencing as well.
Okay, thank you very much.
Thank you for your presentation. I was just wondering, what do you think there is no difference between diversity on admission and the ICU and later? Because I would suppose that later it should be decreased because we give antibiotics, we do a lot of things with the patient. The time between the two measurements is too low, or what do you think?
Yeah, that's another very good question. I'm very happy that your attention tenacity was so high before the coffee break. Partially, I think it's because the illness severity itself is causing great harm to the microbiome. But partially, I think that this kind of analysis is not good. It's bad to detect these differences, because I strongly believe that those interventions are causing dysbiosis, but just pooling these data together is just not getting the results nicely.
Thank you.